these are megapascals already.
Oh.
Oh, let's see. So is that a capital M, P, A like that? Oh, yeah, something. Tell me what I do.
Yeah.
Is that right?
Yes.
All right. Because Pascal was guys too. All right. So are those megapascals? In fact, we had newtons per square millimeter. Okay. And I think I did a little aside out there on the assignment that hopefully proved that is in fact the way to get. That's a nice, convenient way for our purposes to get megapascals. So how do we find the ultimate tensile strength?
The bigger one.
Huh?
The bigger number.
The biggest number. All right, there's 2.4, 7.16, 7.9, 8. 6 hours later. All right, what's the how? Okay, yeah, you could sort it. Let me encourage you, if you ever do a sort like this, if you just find yourself wanting to sort a bunch of data, and someday you will. You don't need to in this particular case. But if you do, let me encourage you to put an index column next to whatever it is that you're sorting. Okay, like 1, 2, 3. There we go, like that. All right, to preserve the order that they were originally in, so you can unsort it back. Okay, so understand what I'm saying? You will find yourself at some point in time. I promise you, you will want to sort a bunch of data. And what may happen is you get this thing, you sort, if you sort by any of these, you're not ever going to be able to undo it. I mean, you can undo it, but if you do some other things, you'll have to undo all the way back until you get it back in this situation. So always give yourself an index that you can unsort with, that you can get it back to the original sequence.
Just copy it, like another, just make a copy of it and sort it.
There is a sort function in Excel.
Yes, there is. There is. But my point is this. There's not a put my data back the way it was function. Okay? So come out here, get rid of that column. And we can come over here and you could say data, whatever it is, sort. And I can sort by any of these. I can sort by megapascals, smallest to largest. Let's go largest to smallest. There, I can do that.
But it still doesn't match.
But getting it back the way it was, I mean, I can undo it at this point. I can still hit undo. But if I come over here and start doing some other stuff, whatever else I do, I've got to undo back all the way through all that. All this work is lost, is my point. I can't, there's no way that I can sort this ever again and have it be the way it was. And that's why I was saying if you had the 1 through 500 over here, you could sort all of this by that first column. Hopefully that makes sense. I'm just trying to help. All right, so I already know that it's not going to want to do a scatter diagram of stress and strain oriented like that, so let me just try doing this. What do you do? Insert this little thing, scatter, there. All right. There you go. So what you can do is pick out some data points from, say, there to there. Get that. Let's try to plot, let's trim off this data. Let's get out here where we think we're at the 0.2% offset. All right, that's at where the stress is about 387. So let me go down to about that range. Oh, come on. Oh, did I put that way down there? All right, so right there at about that level. And I wouldn't want to delete this. Obviously, we want to copy this out somewhere else, but just to avoid having to do a bunch of work over again, just to show you what I'm trying to do here. Why did I put my graph where I did? Okay, we'll just forget about that. I'll just make another one for heaven's sakes. I'm showing y'all bad stuff. Sorry. There we go. All right, so what's happening here is it looks a little funny. What happened? Why does it look so funny like this? Why is it stretched out? Well, you again, because I took and I deleted off most of the scale. All of this was pretty well vertical. This is just that very, very first piece of this. Look at the X values down here. Oh, 0.002. There it is right there. 468. These are little tiny, tiny, tiny values. So all this is happening way in that very, very beginning of the graph. So don't be concerned. Don't let that alarm you. We can get ourselves a couple of different values there. And we can calculate Young's modulus. You can just tell we're going to get different values. Okay, so there's one. You could write that down. That would be, well, we'll start down here with like 0.1 would be something like this. 0.000565, and then 34 or 35 point, etc., etc. The other one, that would get you a second data point. So what we want to do is draw a line. We want to come up with some kind of equation for a line, okay? And we want to plot some points on that line, right? So this line is theoretically what? It's y equals mx plus b is the nice way to write that, right? So the equation of this line would be y equals, what did we say, 100 and how much? What was m in this case, which is actually e for our purposes?
136,669.
We'll call it 137 thousand, right? Times x plus our y-intercept here should be 0. We'll use 0. So that means that what I should be able to do is make myself some data points that work that same way. Okay? So over here, I'm just going to make myself a second sample set, strain, and my stress values. It's my stress value is what I'm gonna give it some strains and get some stresses, right? Let's see the way it will work. Yeah, I'll give it some x values and it will calculate for me some y values. And our x-axis is our strain value. So let's come up with some strains. 0, 0, 0, 0, 1. Let's look at our graph again. Just want to make sure that I have something to lie on here. If I go out to 0, 0, 2, that's about as far as I want to go. So let's do some others. 0, 0, 1, 5. Or I'll do this one. 0, 0, 1, 1. I'm going to do that anyway. 2, 3, 4, 5. Keep going, it's just that one. All right. Our Young's modulus, E is 137,000. So this is our x, this is our y. So this, y equals m, lock it in, times x plus 0, right? All right, so now y'all are gonna have to help me out. How do I add a series to this thing here? Select data, can I do that? Get some more, can I get another series? Add a series, series name, 9, series X values, does this work? They are these, the back, series Y values, these, doesn't work? Ah, yeah. Does it look like it matches? I don't know, more or less. Not too bad. And now I can see that I would have been better served starting at a little bit smaller number. So now that this is plugged in and working, maybe I would do that. I don't know. 0.5. I'll just pop those in there so we have some further down. Okay, y'all see what's going on there? All right, so I'm convinced those are okay. And you know what I could do is if I had myself a ruler, I could draw that in there, but there's really no point in drawing it in here, is there? All we're doing here is just kind of saying, yeah, it's within the realm of probability that those modulus values are the same. Y'all see what I'm saying? It looks like those two lines are fairly parallel. It looks like we have a model for our data. Okay, I am convinced. Now, what we'd really like to do, now what you could do is you could lay this out. You could print it out. You could get yourself two triangles, and you could take yourself back to Tech 1711. You could lay a triangle there. And you could slide it over until you hit 0.002, which is where our 0.02 offset, 0.2% offset goes. And you can go out and find where it intersects right there. And it looks to me like it's going to be somewhere around the 300 mark, 300 megapascals. How can we actually shift this line over? Should we add it? But yeah, if we come in here, we sneak in here and modify that x. That'll do it. And I'll just tell you, this is one of those things I always forget. What do you do to the x? Is it x plus 0.002 or x minus 0.002?
It should be minus.
Yeah, it should be minus. All right, it moves it
Let's move to the right.
this direction. And if you need to, what you can do, y'all know about this. I have a link to it because I like using it. It's a fun little thing. This little Desmos calculator. This is what they should issue to school children instead of those damn HP calculators that are so expensive. They should give them these and just tell them it's a game. Okay? Let's see, this is y equals our m. What's our m? 100. Okay, I'll remember that maybe something. 137,000 times x. Let me just say times x. Plus b is plus 0. There's our line. It would be more interesting if we were to change this, change the range of this something smaller. What is that? How do I do that? Projecting mode. I'll do that. Oh, I need to start at 0. That's what it is. Okay, so x. This goes from 0 to something like 0.1. There we are. And in fact, 0.1 is a little bit big, isn't it? About 0.003. Okay, so there is our unshifted line. I'm just going to trim off one of these so you can see a little better. Okay, I just changed our Young's modulus. You see how we changed our modulus of elasticity? It's reflected in the slope of that line. All I really want to see is I want to show you all, that we can move this thing left and right, which you already know. You just may have forgotten. So we take x and minus 0.002. There, we've shifted that line over. All right. Just that much fun. All right, so what we need to do is do that in Excel now. So we went out there and kind of prototyped it, and we said, yeah, okay, we can do that. All right. So what we're going to do is take each of these values, and this will be our shift. 0.002. take each of these values, these are our x values, and what we say, subtract this, lock it in value. What did I do wrong?
You're going to shred.
Huh?
You're going to wash.
Oh, yeah, they're flipped around. Okay, dang it. Y equals m times x, but that's x minus, oh, I subtracted strain off of there. Wait, what's going on? I wanted to do that. It was m times x minus, so that, oh wait, yeah, no, that's, okay, yeah, that's the effect. All right, so what we really need at this point, see, it's shifted, but we just, we haven't got big enough values yet for it to come out there and intersect. So these need to grow and become bigger. They need to get up higher so that we'll actually poke through that graph there. All right, so instead of using these strain values, we'll start at a point 0.002, and we'll grow from there, 0.0021, 0.022. Does that make sense? Y'all see what I'm doing? There, and you see I'm still not there because I've got to raise that thing up, that line. But I actually have what I need, so I can lay that thing down. But in the interest of, let's see what that looks like. No, that's too much. Still kind of big, huh? All right, there. I like that. Okay. So what that tells me is, look, probably if I found the average between these 2 points right here, I'd probably be pretty dang close to my 0.2% offset yield. Y'all understand that? I think that's a pretty good way to do it nowadays. You used to actually do this physically on a piece of paper and lay it out, and like I was talking about with the triangles, this I think is a little bit better. And a clever student could write a little script that would probably go in there and do that, but it's basically all done now. If you had another set of data, you could just pop it in there and basically get the same stuff. All right. All right. So that gets us that. Any other items? So we got ultimate tensile strength. We got 0.2% offset yield. We got Young's modulus, our modulus of elasticity. And I'll just say, guys, show me how you get these numbers, and I bet no two people are going to have the same modulus of elasticity. Okay? And there might be a little bit of variation in here, but they're all going to be within a very tight range. But there will be some variation there because everybody's modulus is going to vary just a tiny bit, so you might be shifted more towards one point than another. Percent reduction in area, the percent elongation, all that should be in your report. Do keep in mind, I don't need a lot of flowery language in the report. I'm not looking for that. I do want you to use some technical terms. Write for a technically literate audience. Write for, it might help you to write for an audience of people who were sophomores in engineering technology, but who were majoring in like computer engineering technology type fields. Okay, so that sort of level of technical, I don't want to say jargon because really you don't want to use jargon. You want to be, I don't mind you defining things like ultimate tensile strength. Okay, that would be good, I think. But you don't have to rehash everything. You don't have to tell me what a scatter diagram is. Okay, I don't need that. Nobody in engineering technology needs to know that. Yes.
This is our only report, we're only writing a report for this one lab?
Well, I didn't quite say that.
I'm sorry.
Okay, but yeah, this is one of the primary ones. Yeah, and this is